All right, welcome back, everybody, to another live stream. It's been a while, maybe even a little over a month. So I apologize for that. It's just been it's been a little bit of a busy time, not in a bad way. It's just that like my family and I have just been doing lots of stuff, and then just transparently, like when new video games come out, like pretty much anything that is not required of me goes out the door. And since this is just a fun thing that I kind of do on the side. Let me just check my audio really quick to see if it's working out. Okay, my audio is working okay. So yeah, it's been a while. I got, just a fun thing. Like I got a Steam Deck, and so I've just been playing the heck out of that. So I've been playing Elden Ring, been replaying God of War in preparation for God of War Ragnarok coming out later this year. So yeah, when this happens, and this is just like kind of like a little bit of a life tip for anybody, because I've had people ask me all the time, like, how do I not get burnt out doing blogs or things like this? And the simple answer is I used to try to adhere to a cadence of I will do X on X like every single week, like I'll do 2 or 3 blog posts a week or something like that. And the problem with that is when you put guidelines around that, then you feel like you have to do that all the time, and then you get burnt out. And so I think I committed to myself like a year or two ago that basically just said, like, you know what, when it comes to this fun stuff that I'm not getting paid for, and it's supposed to be fun, if I go on a break, then I go on a break. And usually it happens in the summer. Like it doesn't it only happened this winter just because we had some pretty big video games coming, like Elden Ring, like I mentioned, and Horizon Forbidden West. And so, I'm not going to beat myself up over having missed a month. But we are back. And yeah, I will admit I'm a little bit unprepared today. I was hoping to be a little bit more prepared. So I on Fridays, I get off work typically about 11. And then I'll do some prep to do some work. However, I just found out from a friend of mine that is helping with the Art Expo that's going on in Chicago this weekend that he can actually get me in for free. So big thank you to him, and I'm excited about it. However, I've gained a little bit of weight over COVID, and thus my nice clothes don't fit me. So right after I got off work, I went over to the mall and bought myself a new outfit for tomorrow, and thus I am sliding in hot. I don't even have, like, my wife criticized me that, I don't even have my classic beverage, like my classic big Polar Pop that I usually get, because I just did not have the time. And so I'm pretty underprepared today. So that enough with the introduction, enough with the waffling. So what are we doing today? So this is kind of a continuation of a previous stream that I did, I think, back in November. And in that stream, I introduced the concept of computer vision. And I also did the same thing in blog form. And actually, Toward Data Science, the publication that I publish all my data science blog posts to, actually featured that computer vision article that I wrote in, like in case you missed it kind of thing. Like, here's a couple of good articles around computer vision, and mine was one of those recommended. So that was pretty cool. But the whole thing that kind of spurred this on was I am, I work at State Farm, and State Farm has a partnership with the high schools here in town that they go through this program. So what this program does is you start as a freshman and you do it all the way freshman to senior year. And you take all these different computer science kind of classes. And then at the end of the 4 years, presuming that you made it through all the coursework and everything, then not only do you graduate from high school, but you also graduate from the local community college, Heartland Community College here, with an associate's degree in computer science, which I think is a really cool opportunity. So, I really like that State Farm is doing this partnership with them, and so I'm able to and I've been doing this now for 3 years. So I started with the incoming freshman class. They are now in their second semester of their junior year. And so as part of their whole thing is, like, they have to do this big, massive project that they got to choose of their own accord. Of course, it has to be data science, or not data science related, computer science related. And these guys happen to choose a project of computer vision. So I've explained this project before, so I apologize if you've heard this before, but it's been long enough that I feel like I need to give a recap. And what this project is doing is so they want, part of the problem whenever the students leave school, at least the students who drive, is that just a ton of parking lot congestion. And so it's gotten so bad to the point where, like, some students have pretty much just said, we're just going to hang out in the building until the traffic lightens so we can just leave our cars. And so that what they were thinking is, okay, is there a way we can use computer vision to assess how long it takes a car to get out of a parking lot? That way, if you're parked in like the back corner of the parking lot or the front side of the parking lot, like, can we give you a time estimation on how long it's going to take it to get out of the parking lot? So what they want to do is they want to use a computer vision model with a camera to actually basically look at how long it takes for a single car to get out of a parking lot, and then start doing some guesstimations, if you will, on how long it would take to get them out. Now, so just a little bit of transparency there. Obviously, there's a lot of weird legal issues and other issues with like the school district wanting to do that. So I actually don't anticipate this manifesting into something real, like where the school would actually implement this. Although it could. But just for all, you don't want to, obviously the students would need access to the school's camera system, that's got to be a red flag. But from the pure perspective of learning, I like the idea. I love the idea. And especially for me, because, so there are 4 of us mentors with this particular class, and they pitched their ideas to us. And I gravitated to this project because it is computer vision related. And I'm not strong on computer vision today, and it's something that I wanted to learn alongside them. So it's been a great learning experience. There's a great group of guys, and so I've done already like a solid 5 minutes of waffling. So I'm not going to cover the concepts of computer vision today. Again, I already did a previous live stream on that. I've got a robust blog post on that. So this is really going to be a hands-on presentation, like a hands-on live coding, watch what I'm going to do, and let's figure it out together kind of thing. And like I put, I think I put it in the comments down there, whether you're on LinkedIn, watching via LinkedIn Live, or if you're watching on YouTube, please feel free to drop any questions along the way, and I will see if we can, I'll answer those for you along the way. Okay, so one thing I do want to show you, and I think I've showed this in the past, so I do have you could see kind of over here, there's like a fake parking lot with some fake cars. Actually, let me go ahead and show you this. There actually is another web camera back here, way back here. So you can see that I've got actually my typical webcam. So this is just for me, but then I have like what I call my demo station web camera. And so you can see here, when we actually start to enable our computer vision models, this is how we're going to test it out, is because we want to, I don't see it, I kind of generically named this live stream because I don't know how far we're going to get today. But we're going to kind of take baby steps. We're going to figure out little pieces and go forward and keep building on top of this. So I can definitely say we won't finish this project today. That's 100% for sure. But we'll see how far we can get. So this is our little demo station over here. Okay, so let me go ahead and share my screen, and let's start talking through some of this code here. So one of the primary Python libraries we are going to be using for this project is called CV2, and CV stands for computer vision. I don't know if the number 2 has any significance. Well, let's look it up. Sorry, that's not what I wanted. All right, so let's go ahead and blow this up, and CV2. Okay, so OpenCV Python is the old interface. Okay, I forgot. This is actually called OpenCV. So this is the framework that we're going to be using. Let me take down my demo station so you can see this a little bit better. Screen share. There we go. Take down the demo station. Okay, so what we're going to be doing is we're going to be making use of CV2 here in order to start working through each of our pieces here. So I already started to write a little bit of a script here, but let me go ahead and I personally like to heavily annotate my code and stuff, and so let's go ahead and walk through what this very basic script here is doing. And I'm just calling this the video detection Python file over here on the left. So what we're doing is we're making use of the Computer Vision 2 or OpenCV2 library here. And then the first thing we're going to be doing is we want to instantiate our video capture source. So the nice thing with OpenCV is you can actually do a number of different video capture sources. So like in this case, we're going to be using a live camera here. So my live webcam. but you could theoretically point it to a file, like let's say you've downloaded some MP4 or MOV or some other AVI, whatever, any sort of already file that already exists, and you could pump it in through this way. I'm not actually, let me take that back. It might be a different function, but you can, basically what I'm saying is you can use CV2. I don't know if it's video capture per se, but this is what we're doing. So that's, like I say, I like to annotate my comments or code here. So we are instantiating the object for the video capture here. The only thing that I'm not wild about, and I tried, like the documentation here is not great, like transparently. And so the documentation here, you might be wondering what this number 1 is doing. And what this number 1 is doing is basically like you give it the index value of whatever your webcam is. And so for most people, because index values start at 0, most people are zero is gonna be fine. In fact, so like let's say I was doing this on a MacBook with something with just like one web camera. You'd choose 0 and it would choose that front facing camera toward you. Now obviously I got a little bit of a unique setup here in the sense that like I've got my one camera here, that this is the camera that you're looking at me with. This is not the camera we want to use. We want to use this other camera. And the problem is I don't know which end of it, like because I plug these things in differently, the source always changes. So I don't know if it's 0 or not. So we'll come back to this because we may have to alter this. But basically what this is doing is we're instantiating the object for a video capture here. And then, so this is, I'll go ahead and annotate the code here. So what this is doing here is everything else is going to take place inside of this wall block. While, oh my gosh, I can't say that word today. But this is basically saying, unless we purposefully stop the video stream, and I'll walk through this code. Unless we purposely stop this video stream, this will continue to iterate over and over and over and over and over and over and over. Because basically what we're doing, and this is a very brief recap of the general computer vision discussion, is computer vision, at least when it comes to video, it's not actually analyzing a video. It's analyzing each individual frame of a video. So like video gamers will know this quite well. So what video basically is basically a stream of images all stitched together. So most movies are shot at 24 frames per second. So a frame being an image. So you get 24 frames in 1 second. Like actually, so think about a flip book. Like I'm sure most of you have seen a flip book before. You take the flip book and then let me just demonstrate with any old book here. Seth Godin's Linchpin. I don't know why I picked this one out. And then you just flip through and then you can kind of see an image. Same concept here is, however many frames we're going to analyze in 1 second. So, this is a good book, by the way. Sorry about that. A little distracted. We'll put that back there for now. What was I saying with that? Oh, yeah. So anyway, and what I was saying with video games, how they would recognize that. So, a lot of modern video games, or at least in the last generation, would start at a baseline of 30 frames per second. A lot of action games like to go up to 60 frames per second. I know like Fortnite, you can do 120 frames per second. Personally, like you can see quite the difference between 30 frames and 60 frames per second. I personally cannot tell the difference between 60 and 120 frames per second. In fact, between that 30 and 60 frame per second mark, because I just noticed this because of my Steam Deck, because my Steam Deck will run Elden Ring at 45 frames per second. I actually can't tell the difference between 45 frames per second and 60 frames per second. I can with 30, and if you're curious, most Hollywood movies are shot at 24 frames a second. So a lot of YouTubers, and there's a funny, not funny, but like a lighthearted YouTube debate of like YouTubers saying, okay, do we shoot at 24 or 30? So like one of my favorite YouTubers, a tech YouTuber named MKBHD, he even sells t-shirts that say something like 30 frames per second per life. And, honestly, like, I don't know if I have a dog in the fight when it comes to that, but I do. Basically, more is better. But when it comes to computer vision, I don't think you you definitely don't need to analyze 120 frames per second, because basically what you're looking for is a pattern in the video. And so, I think in most cases, 30 frames per second will work just fine. In fact, I haven't even gotten that far in this. But basically what I was going for here is when we do this while true, we are getting the video stream, but we are reading this thing like at least 30 times a second. So that's what this thing is doing, is this loop here, lines 8 through 18 here, will continue to iterate through every single frame until we tell it to stop. Hopefully that makes sense. Okay, so what we're doing here is, we have the video frame or video stream object that we are reading from, and I haven't looked up what this ret is. I think what this ret is basically saying is, if I think it's a Boolean value that basically says, okay, we can get to your camera or we cannot get to your camera. I've actually not tried. I know I put this in a container directory because I like to Dockerize everything. I actually don't know if this would work in a Dockerized container. And the reason that is because Docker emulates kind of its own environment, meaning that I'm sure I could figure out how to enable this, but by default, I don't think that my Docker environment would be able to recognize the firmware that is my webcams here. So so that's what this is doing, is basically saying, okay, if we can reach out to, and maybe I need to look at the documentation here, because I just copied and pasted this transparently from somewhere else. So I don't know what this actually is. Part of the problem is that the OpenCV documentation, I think I just mentioned this, is not very good. So let's see, CV2, or let's just Google here, Python CV2 video capture. Okay, because I usually, because people like to rag on people that go to straight to Stack Overflow, and I'm one of the people that actually, you can even see this. Look, when is 4.7? So this was yesterday. I visited this page yesterday. I visited this page yesterday. I actually do try to look at the documentation, but the problem is if your documentation is not very good, then I'm not going to use it. So, and unfortunately, that's more often than not, even the official Python documentation, I think I've said before, is not very good in my opinion. It's just super confusing. So let's look at this here. So this is, I just Googled Python CV here. Now, of course, I think that this is written in C under the hood, but the problem here is I don't see any good Python examples, and moreover, I don't know. So I actually don't know C++ very well, but to me, this looks more like R. Like the R language. Again, that's why this is frustrating, because I wish because Pandas, for example, is actually pretty decent with their documentation. Pandas will tell me what the let's just show you an example. So Pandas read CSV. So there's a very common function for reading in function. So you can see here, it gives you every parameter, tells you what each is supposed to do, and then you scroll down even further, and then it'll tell you what a return, or the property about what it can return. So it'll return a data frame here, and then you can do it so this was probably a bad example because this is pretty straightforward. But you can see even with the parameters, it'll tell you what is you need to go into it. I still don't know how to read this thing, so this, okay, but this is kind of confirming to me that the file, the parameter can be a file name for here. Oh, well, I don't know. This is confusing. I don't know how to read this documentation here. So if anybody contributes to this project or contributes to this documentation, please fix it, because this is confusing. But what was I getting at here? But yeah, basically I don't know what function were we trying to read. So read. Let's do a control F for read. Okay, so Boolean read. Sorry, giving my voice a chance to catch up with itself. Okay, so C also read. Okay, so read parameters, images is the image, the video frame is returned here. If no frames has, okay, so returns false if no frames have been grabbed. Okay, so the combines the retrieve and the colon, blah blah blah. So yeah, I still don't really know what this is returning, because read this with me. It says it returns a true or false. Okay, it's doing more than just that. Because this code works. All right, I need to stop going on a angry tirade about how this documentation is not very good. But basically, the way I understand this is that this read is doing two things. It is returning a Boolean value if it can actually get to your camera or not, and it's returning the frame itself. So that's what this is doing. It's breaking the loop if nothing is returned. Okay, So next up, I do understand this a little bit better. So what this I am show is doing is basically, okay, it is we're taking the frame that we want to display and then actually outputting it to like a window, and I'll show you that here in a second. And so here's the other interesting thing, and I actually did not read what this syntax is actually doing, but what this is doing here, and this is required because well, actually, let me show you what happens if I try to run this without it, because this is interesting. I did not realize this. So I do have an open terminal down here, so I'll go ahead and cd into the container, and then we'll so this is the video detection Python file, so we'll do Python video detection.py. Not Python, no. Might help if I spelled that right, and I know you can't see that around the logo there. So okay, so what this should do, it should pop up another window that will, where is that? Is it anywhere in here? Hello? Anywhere in here? Tried, but okay. Has an incompatible architecture. Okay. All right, so it's been a little bit, but I've had issues with my Mac Mini. So I think I've shared before that I use a one of the newer M1 based Mac Minis, and you know, I like it because it's speedy, but it has been such a pain in the neck, like transparently, because it's got that new Apple Silicon architecture in there, and so like I tried getting TensorFlow on this machine and had some major issues with that, and I think it wiped out pretty much all my pip stuff. So let me try something different. All right, so cd cp parking lot ls. All right, so python test.py. So let's see if it, okay. Oh wait, no, this one is actually working. Okay, do you see that? So pretending like it wasn't gonna work, and then it started working. Okay, but all right, so Mako, so that needs to have some sort of architecture, blah blah blah. I did, because I didn't see this before, but you can see that this is actually kind of working, but it's in the looking at the wrong thing here. But you can see here that it is like this. I don't know why I have this printed. This is just like the dimensions of the file. But you can see like it actually is working in the corner up there. So let me go ahead and shut this down for a minute, and we'll see if we can figure out what's going on here. All right, so let me go into this file out of curiosity. So it is using index value 0, so src equals 0. I was trying to get it, because this was just an example effort that I found from online, but it's using this library called imutils, and I'm not opposed to using other people's libraries. However, when I look at, because you can look at the history of these things, this thing is not supported anymore. So, or at least it doesn't appear to be supported. It's been a long time since it's been updated, and so I try to steer clear of things if they're not going to be maintained well, which so CV2 at least is. And like when I look at what this imutil is doing, it's basically just under the hood. It's doing some like simplifying what CV2 can do, because I don't know why. So let's see if this will work out again, except with my other camera. So all right, so let's try this again. Okay. All right, it is working again, although I got that weird error message once again, and I don't know why, but you can see now that we do have my car's over here. Let me go ahead and do the screen share with the demo station, and let's go ahead and make this a little bit bigger. How do I make this bigger? All right, come on, arrows, there we go. All right, so you can see that I've got, so this is a generic model, by the way, that I found and am testing with. So this model is designed to recognize a number of different objects. So you can see like it thinks that my thing here is a chair, which let me see if I can tilt this camera down even more. There we go. That's a little bit better. Okay, so you can see that it thinks that, what is this? It thinks that this is, well, no, nothing, but I thought my hand was something. Which, by the way, when I do proceed along further in the project, obviously, whenever we have our hand in here, you know, my hand is being recognized as something, so you don't want to have any outside interference. So what I did was, okay, where's that? Whoop, I messed up my camera there. I bought fishing line, as you can see here. So this fishing line, I will wrap around one of these cars. That way I can pull the car along and like camera, like basically so my hand is not interfering with stuff. And you can see my dirty office right now. Like I said, I'm wildly underprepared today. And like everything's kind of a bit of a mess right So apologize for that, but it's not too bad. My office could look worse. It's looked worse before. Okay, so putting my things back here so you can see. Now, one thing I do want you to notice. So if you look at the top corner of your screen, where like like the one that's got like the rounded corners that's a view of this, it has a higher resolution than this. And so the reason that is here, let me go ahead and shut this down because we don't need to keep this for now. And the reason this is because what the computer vision model is doing is basically combing over every single pixel in the image, and then trying to find a pattern amongst the pixels. And so if you try to keep it at its native resolution, which is what makes the screen the image quality looks good, the problem with that is then you have a ton of pixels, like way more pixels than you want to like go over. So what the reason it looks different is because what this person did, and this is not my code again, what this person did is they resized the frame to that way there weren't that many pixels, and then you could do a more computationally quick thing. Because I actually think, now that I'm remembering this, I tried to alter this and just remove this in the last live stream, and it caused such a performance issue with my computer that I think it almost crashed the live stream, or it froze the live stream for a minute. And I don't want to do that again this time. But while we do have this gentleman's code up, let's look at it, and because I can talk through it a little bit better now that I understand it just a little bit more. So what this is doing, and actually this is what we're going to be doing with our project, except I don't want to use this particular model, is we are going to be using a pre-trained model to recognize cars because we don't need to train our own thing. I don't have the resources to train a deep learning model anyway. Well, I guess I could if I use cloud, but that can be expensive because basically like the way you train one of these models is you have to feed it a bunch of images of stuff like cars. And then you have to create this deep learning neural network. And I know how to do this. It's just that in order to do that, I need two things. One, I need a heck ton of pictures of cars, which, I could probably find, but that would be a big pain in the neck. And then I would need GPU time in order to train the models. And I don't want to spend the money on that. And so here's a fun fact, and I think I mentioned this in the live stream before. GPUs aren't really, what's the word? Efficient in the sense that they just use a lot of power and stuff. So actually one concern that I've read before is that GPUs are not environmentally friendly in the sense that I think it's fine if Google has created these models. I'm jumping ahead a little bit, but basically what I'm saying is we are going to use a model that I think Google trained, but Google will have these models run against hundreds of thousands of images, if not millions of images for weeks at a time. That imagine if everybody did that. If everybody got their own GPUs and started doing that, that's going to be really environmentally unfriendly. And so that's another, I guess, that's this, let me be honest, that's not the primary reason why I'm not going to do a model train. The reason I'm not going to do a model train is because I don't have the GPU resources and I don't really have the images, and I don't want to. I guess I could have AWS SageMaker run my model for me and train it for me, but that would get really expensive, especially if I did my diligence. So basically what I'm saying is let's use a pre-trained model. But the pre-trained model that I picked with this particular gentleman here was trained to be more generic. So you can see with all these classes here, it can recognize airplanes, backgrounds, bikes, birds, boats, and car is just one subset in here. But as you saw here when I ran the model here, and I think it might just be because my desk is too dark, and in fact I'm rethinking if I need to get a poster board or something over here. That way I can have a little bit of a lighter kind of thing, because I think it might be almost too dark. But it's not recognizing cars well. So, and I think you saw that when I turned on this model. So that's one thing I do want to get to is finding because I know they exist. I just haven't tried this yet. How do I get a better model specifically for cars? So that is one thing we want to do. But let's go ahead and talk through this guy's code here anyway. So I like to. So this is his code. I did annotate it with some comments but I didn't understand exactly how it was working before, but I do understand a little bit better now. So basically what's going on here is, we have all these different classes, and what these colors are doing is basically saying, okay, and you saw this when I started up the model, is he wanted, let's say cars, anything that is recognized as a car will have a red a red border around it, and those borders, those little boxes that we saw, those are called referred to as bounding boxes. So a bounding box is something like where it'll create this box around what they think the object is, and so that's what this colors is doing. Is it's just assigning a unique color to each one of these, and it's a random each time. So using NumPy to randomize that, and then here we're actually loading in the pre-trained model. So this is. I don't know who trained this model. I don't think this gentleman did. I think he also just took this from someplace else. But this is basically saying, okay, CV2, I want you to read in this deep neural network. This is a CAFE model. So CAFE is just another flavor of deep learning. We got TensorFlow, we got PyTorch, we got CAFE, we got a number of different things. So just loading this up so you can see this is actually loaded up from some static files here. Actually, I'm curious, like how big are these files? Let's look real quick. So LSCD models, and then ls dash, not ls dash LH, I think is what I want. Okay, so 22M is, so 22, oh wow, that's actually way less than I thought it would be. So this is actually a relatively small file here. Okay, but basically I needed to find something different, but this is the model that he is using. So you can see here, again, he's making use of IMUtils here, so the syntax is going to be a little bit different, but again, what I found is that this IMUtils is really still using CV2 under the hood. So even though it looks different, this is CV2. And I don't know why he's doing some of these things. I'll just be transparent, like if I don't know what's going on here. But so same concept here, reading in the stream, and then continuing to iterate through the loop here. I wonder if that's why this didn't work. Is because I bet that's why. Okay, I am all over the place right now. I'll go back to why I don't think this worked. But anyway, so he's getting the frame from the image, doing a resize. Getting the height and width of the image, and then resizing the whole frame. Like, so he's, what is he doing here? I actually, I'm going to be transparent. I don't know what the difference between, well, okay, so this would just be the frame, but I don't know what he's doing. What is he doing with the image here? Oh, okay. Okay. All right. So from the image here, okay. And this is, again, where I'm a little bit hazy on what he's exactly doing here. But so this is the CV2 deep neural network, blob from image, resize image. So it looks like he might be doing, if I had to guess, actually let's go ahead and Google this. What is it called? CV2 blob from image DNN. All right, CV2 blob from image. All right, blob from image. How this works. Okay. All right. So. All right. Today's blog post. PyImage, blob from image function. You see the obtain prediction for you need to. So I guess it was some pre-processing sort of thing, and this is affirming that. No, I'm not feeling lucky. Get out of here. All right. So OpenCV's deep neural network contains two functions that can be used for pre-processing of images. Okay, so it is doing some sort of pre-processing, but like, oh my gosh, get out of here. All right, so these two functions perform mean subtraction, scaling, and optionals. Yeah, this is another thing that people do that I don't like that they do, and this is not just this gentleman, but like every single person does this. Is so like as long as like as far as Python function writing goes, is like as long as you get the parameters in the right order, you don't have to specify the parameter name here. So like you could see, like he actually did this here. So swap RB. So I wish people wouldn't do this. I wish they would just write out the whole parameter, because I don't know what this represents. Now I got to go find out what this represents. And like I said, the CV2 documentation, not great. So blob from image, learn OpenCV. All right. So you can even see like when I Google this, like the actual documentation isn't the first thing that comes up. So CV2, blob from image, Python. Like, where is the official document? Okay, so is this the official documentation? Blob from image. Okay, functions. Well, I thought that was right. Blob from image. Okay, so it looks, maybe this is it. I don't know. But basically what I was saying here is I don't like the fact that like this person didn't put these other things. Okay, so it looks like, okay, so you give it the image. All right, so that makes sense. Double scale factor. I'm sorry. This isn't a double scale factor. This is just a scale factor. So looks like he's doing some sort of scaling. Size. I don't know what the size here is doing. So let me open this in a new tab. See if I can figure this out. Size. Yeah. It's this sort of stuff that makes me mad. Like, just okay. I want to understand what size is, but this isn't like, linking off a heck ton of examples. This is frustrating. Okay, so I don't know what size is doing. It looks like there's some sort of scalar value here, and then we did see like he does have the swap RB. So let me go back and look. So this makes sense. So this would be the scale factor. All right, so 0, 1, 2, 3, 4. Okay, so let's see. Are there that many? 0, 1, 2, 3, 4. Okay, so he actually does. So this would be the size. Okay, so 500 by 500. That is correct. And then the scalar value. So it looks like Okay, looks like this is a scale value. Okay. All right. So the way I'm interpreting this, okay. Yeah, thanks for joining, Kat. I see your comment there. I'm gonna type to you just in case you see this. Thanks for joining. Yes, let's catch up indeed. Smiley face. All right. Yeah, thanks for joining, Kat. I was just responding to a chat in the LinkedIn live here. So from Kat Hernandez, super nice person that I've met through State Farm. But anyway, so coming back to here, so basically this is doing a pre-processing on the image, and then we set our input here for the model, and then basically what we're doing is this is the thing that's actually getting the predictions. And so then what this is actually doing here is it's actually looking for like whatever predictions there are. So like I said, like we got our number of different classes up here. So what this is doing is basically saying, okay, I want to figure out which predictions, like, so these predictions are going to have you can associate a confidence value to them. So like it's not going to surface a something that it doesn't have. That's actually a pretty bad confidence value. I would actually change this to 8, because basically what this is saying is if confident, we are have at least an 80% confidence that this is a potted plant, for example, or anything else. So and then it's basically creating the bounding boxes here. So it's basically saying, okay, I want to get the index value from this prediction. I want to create the bounding box like this, and then we actually create a rectangle using CV2 like this and putting text on top of it like this. To basically just generate all of the bounding boxes that are going to be appropriate here. So, and then finally, we show the outputted frame. And so here's what I was talking about here of what I forgot to include, and maybe this is why it didn't work. So you actually have to apparently include a key that will break the loop. So that's what this is doing is here is it's basically saying, okay, as long as this script is running until somebody hits the letter Q on their keyboard, it's going to keep going. And so that's why I think this didn't work the first time, is that I commented this out. And so I'm still curious why I got that error message though. So let's come back to here now. So cd into container. Okay. See Python video detection.py. Okay, so this time it actually is working. Because basically the only thing I wanted to demonstrate here is like if you wanted to start up just the video alone and capture the video as a Python image or as a Python thing, this is it. And actually, I now that I think about it, because for this particular project, what these guys want to do is they just want to see how long it takes to get out of the parking lot. Like the video capture stuff is cool. Like, don't get me wrong, like this is super cool, and I think it's going to be very important for validation that your model is actually working. But I don't think this is actually required. Like, so I could actually start this here out of sheer curiosity. Let's go ahead and try this out. Here, and I'm gonna. And this is the other thing I've noticed is like even though I hit this letter Q, like it never works. I always have to do the Control C. So I don't know if it's just me being stupid or what. But I also don't know what the syntax is right after threw I'm a little bit thrown off of why they threw some random hex back there. But anyway, so I'm wondering if I comment this part out, will it still run? So let's try this out. And the answer appears to be yes. Obviously, you can't see anything, neither can I, but It appears to still be working. In fact, let me go into. Let's go back into this other gentleman's file here. So, because he was printing out like something. Is there print? Okay, he was just print. So, like whenever we were writing this, we actually could do this here just to like really kind of drive home that you can. Like this is still working. All right, so print frame dot shape. Okay. All right. Let's see what happens if we run this again now. All right. Video detection pi. Okay, so you can see that this is like you can't really tell, but this is adding. Well, you can kind of tell. Like well, let me get my face out of the way. So look at the. Well, how about here? Look at the scroll thing here. How it's slowly moving up, and the reason it's slowly moving up is because every second we are getting this here. So the resolution on here is apparently 1920 by 1080, and then you might be wondering what the 3 is. Well, 3 refers to how many color channels are coming in. So and I might as well. I'm basically doing the other video over again, but basically like when it comes to an image on a computer screen, you basically have these little tiny pixels on the screen, a red color channel, a blue color channel, and a green color channel. I set that out of order, RGB, red, blue, green, blue, and like each of those represents a color value. And so if you, like for example, if you wanted the color purple, you would light up the color blue all the way, and you'd light up the color red all the way, but the green color channel you'd have totally turned off because, obviously as we learned in preschool, red and blue make purple. Okay, and so so this is working. I'm very curious how many frames per second that was. Yeah. So how much further do we want to go? Because we haven't gone that far at all anyway. But yeah, so I do want to add another comment here. Continuing the video stream until it is forcibly stopped by human intervention. Okay. All right, and so here I want to add a comment here denoting the keystroke that should be pressed to stop the video stream. Except this doesn't work. I've already noted that. All right, so if key, actually I'm wondering if I could just do this. Let's see if this works. All right, let's try this out. And let's rearrange some stuff here. All right, so let's come back in here. Okay, so it is working, and yeah, very good. I still don't know why these plugins aren't working all right. It's incompatible. Yeah. So this is again what I'm talking about with this Mac Mini, and I don't regret it because obviously Apple is going all in on their architecture. It's just that the early days are tough. But basically, like the former Intel chips that were created for like the last generation MacBooks use an x86 x86 64-bit architecture. Oops, sorry about that. x86 64-bit architecture, but now these new Apple Silicon-based chips are more of an ARM-based architecture, and but it's not exactly ARM-based, so it's just been such a pain in the neck to work with this Mac Mini. Again, but it's really like the only issue I've had with it has really just been for development. Like as a personal computer, it's been like fantastic. It's fast. It'll run iPad apps. Yeah, but just for development, it's been kind of a big pain in the neck. Okay. Yeah. Okay, so I guess we do. The next thing I want to look up is an actual model for, or pre-trained model for vehicle detection, because basically we want to copy somebody else's work. Okay. All right. And I just want to be cognizant of dates. I did start to Google this yesterday, and I didn't really see a whole lot before 2020, which is fine. All right, so yeah, video detection and tracking with on toward data science. So what does this person have to say? So this is 2017. I want to try avoiding anything that was too long ago, which is kind of crazy to think that 2017 was now 5 years ago, half a decade ago, but a lot can change that. But transparently, I haven't, because I try to keep up on this stuff, I haven't seen the whole, with the exception of OpenAI, so Elon's company that has been doing like the stuff like GPT-3, and then they came out with another one this week. I haven't seen a whole lot of, I don't feel like the AI space has really moved that far, but in the last 2 years, and I wonder if that's just because of COVID and stuff. But yeah, I just haven't seen. I don't feel like the space has moved terribly far. So if we have to do something from 2020, that's fine. I wonder what YOLOV is. That's the one thing interesting about YOLO algorithm. I've heard about this YOLO algorithm before. So vehicle detection. All right. So what is this person doing? So take or find images for. Yeah, but did this person train it? I mean, I just want to use something like that Google created, just because obviously Google's gonna have had the best resources to do everything here. So, Google, pre-trained car detection model. All right, so AutoML, object detection, vision. Well, I don't want AutoML. Let's see. So yeah, this. Okay, so what do they do? Enables to train custom machine learning models, but I don't want to train my own model. I just want to use somebody else's model. So reference. All right, this might take me a bit. Again, coming into this a little bit unprepared, but more prepared than I've been in the past with other things. I'm all like washed out. The reason I'm washed out is I don't usually have this light on above me, like the main light in here, but I needed more light for my desk over here because you can't see it otherwise. So again, kind of leaning toward like I just need a big piece of poster board. And then the nice thing about the poster board is then I could take it into the school when I meet with my guys. Okay, car detection with YOLO. Autonomous with YOLO 4. Okay, so this is YOLO 4. All right. I mean, this looks good. Like I'm liking what I'm seeing here. So YOLO. All right. So now you only look once for short. All right. What happens? All right. So YOLO algorithm. You only look once. For cars. YOLO for cars. YOLO model vehicle for cars. Guide to car detection using YOLO. Okay. And by the way, like even though I'm also a contributor toward data science, I just can't recommend them enough as far as like a reference guide, because like I said, the official documentation of some of these libraries is not good, but there's a lot of good contributors out here, so I like to reference. Even though I am a contributor myself, I am also a reader, probably more of a reader than I am a contributor, even though I think I have like 30 articles out there. Okay. All right, visualizing the bounding boxes makes impression. All right, I just want to see where the pre-trained algorithm is. All right. Well, the problem is I'm trying to talk and read at the same time, which is never a good idea. Popular algorithm, coding, DNN. All right, visualizing the bounding boxes. Okay, does this person have a GitHub? Okay. What is YOLO? Oh, please don't tell me it's TensorFlow. Not that I don't want to use TensorFlow, but TensorFlow just does not work on my Mac Mini here, just because, again, of that weird architecture. Okay, so conclusion, special thanks to deeplearning.ai. I'll figure. Okay, well, deep learning AI, do you have any... I've taken some of these courses before, but not through deep learning AI. I took them through Coursera. Okay. Here we go. This person's got a GitHub repo. All right. So YOLO. All right. So. All right. What is this? YADAC. Yeah, 2K. Keras. Oh, no, it is using... Alright. Well. Okay, let's see. Alright, how much more do I want to do today? Okay, so... This person... Alright, YOLO utils. Alright, so they are... Yeah, they're making use of TensorFlow. Shoot. Okay. Well, I don't know how much we're going to be able to do today because I haven't gone back and tried to figure out how to install TensorFlow on my machine here, and I've just had such a big pain in the neck with it. It's going to be fun. Well, yeah. It's going to be fun when more people start to use it. I guess the upside is everything in the beginning is difficult, but if Apple's really putting all their chips, which they are, into their own architecture, then people are going to start accounting for it. We're still very much in the early days, though. Like I know Apple Silicon's been out for like a year and a half now, but that is still like my personal work laptop for State Farm is still an Intel based machine, and Intel, and obviously most companies I'm going to assume don't like rush out to buy the newest, latest, greatest laptop. They probably just refresh them every couple of years. So probably in the next 3 or 4 years, when people like these bigger companies start to cycle out their old machines, then we'll probably see more traction and people updating their stuff for Apple's new architecture. But for now, it's a pain. Yeah. Okay. I'm not seeing satisfactory kind of stuff here. All right. Computer. Alright, so pre-trained computer vision model cars. Alright, pre-trained deep learning algorithms. Alright. Object detection. Okay, car classification. Alright. This model was pre-trained. Alright, to develop this model, the car data set. Okay, so this is what I'm talking about. Like I don't have 16,000 images laying around of cars. I'm not even really a car guy myself, if I'm being honest. Like, well, I love my Tesla, but that's about it. Alright, so can I click on this link? Okay, car classifier. Okay. Ooh. Requirements, Keras GPU. Alright, so... Oh, man. This has to be some old thing. Python 3.5? Are you kidding me? That is... Oh, yeah, it is pretty old. Okay. Well, I mean, that was not... When was this? Oh, this is an older article. That's why. Alright. But so, by the way, if anybody is well aware of a good model that I could use, hit me up, please. For pre-trained CNN models. Alright, detect me. Why is it not signing in? Alright, sign in with Google. Okay. Alright, so transfer learning, yes, I know what transfer learning is. Alright, so here for pre-trained, so VGG 19. Okay, so that is Inception v3, ResNet. Okay, well, I don't like any of these. And by the way, this is how I pretty much do all my work, is when I need to figure out what to do for something, I just start Googling around for stuff like this. Okay. Alright, model visualization. Alright, object detection. YOLO TensorFlow. Oh, these are all... Oh, this is interesting. Okay, Keras. There's PyTorch. And then we got Cafe here. OpenPose is the first. Alright, so how about car? If I just do car. Nothing else on this page. Great. Alright, computer. Vehicle. Who is this person? Okay, I also like to check. Well, let me take this thing away, sorry. All right, so you can see up here in the top right where you can see number of forks and stars. That's also kind of how I do like a little bit of a guesstimation to see if I'm onto something or not. It really does kind of surprise me that like that something isn't immediately coming up. Like I would have expected to just Google right away and yeah. All right, got Karen Carpenter in the chat down there. Okay, so all right, so pre-trained. Wait, is this the same article that I read? No, this is one from 2020. All right, so this person is using VGG 16. Okay, here's the architecture. Dang, that's a... Ooh, wow, look at that. 138 billion parameters. All right, training validation, loading the base model, compile and fit. I don't know why these people are like, hey, we got a true pre-trained model, but here's how to train the model. All right, so link to the paper that... All right, so after... Yeah, but I don't have the data. Like, so this is not a pre-trained model. I need a pre-trained model, please. Okay. Pre-training. All right. Let's remove the word pre-train and see what happens. Computer vision methods, but these are methods. All right. Computer vision, Tesla. Yeah, I don't know. All right, vehicle detection. How about vehicle detection? Oops. Okay. All right, so I already visited this yesterday. Okay, this is a pretty recent article. All right. Okay, I like this. I like this. All right, we're getting somewhere. All right, so they're importing some libraries, reading in some image, changing to grayscale. That's an interesting idea, is the idea of switching to grayscale, because the one nice thing about switching to grayscale is you can keep the higher resolution, but it not be so computationally complex, because grayscale only has one channel, and I guess the question is what is more important, color or resolution when it comes to finding like a pattern amongst the data. Like, obviously both together is the best, but from a computational perspective, we got to consider we're going to be running this on what we call commodity hardware. And when I mean commodity hardware, I mean hardware that, some laptop that you can go buy at Best Buy, or whatever. Like, probably definitely too much for like a Raspberry Pi, but like, like my Microsoft Surface. Oops, sorry about that. Keep bumping stuff around. My Microsoft Surface here. Can the model run on something like this? Because obviously, if you had a supercomputer, then sure, throw everything you want at it. But with these guys, my high school guys, I have to be cognizant of, their students working on, run-of-the-mill laptops. So we got to make sure that this thing can work on their laptops. Okay, so dilation, morphology. What is car cascade? So car cascade classifier, car cascade. What is this XML? Okay, all right, here we go. I think we're getting somewhere. All right, now we need a car cascade to detect cars. So we first need to upload them to Colab. You're doing it to Colab, blah, 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 and specify the path car cascade. Then we'll use the car cascade function, to the predefined function of OpenCV, to train the models. Train the images from the pre-trained XML file. Wait, what's going on here? I don't want to pre-train anything. Or I wonder. Okay, here, by the way, is just an example of this doing it. All right, so we started downloading the images, and we saw how using car cascade, which is used for object detection. Okay. So there might be something promising in here. In fact, I'm going to add not a bookmark, but add to my reading list. That's the one nice thing about using Safari, is that it has the reading list functionality, which is kind of like a temporary bookmark, if you will. Okay, so using car cascade. All right. Well, why did it say har? Or was that a typo? All right. Overview. All right. Okay. Is there a GitHub? All right. There is a GitHub in here. Okay. Okay. All right. Okay. This person provides quite a bit of stuff. How long? We've been going for an hour now. Do I want to keep going for now? Yeah, let's keep going. Let's keep going. I'm gonna. I was gonna say I was gonna fork this, but do I want to fork this? Yeah, let's go ahead and fork this. All right, so I'm gonna sign in here. All right. Oop, need my authenticator. Where's my authenticator at? All right. By the way, if you do not have it on your, if you do not have it on your stuff, always turn on multi-factor authentication if you can. It's just an extra layer of protection just to make sure that people don't try to steal your information or whatever. So I have this, I have it enabled on pretty much everything that I can. So obviously I have it enabled here on GitHub. So 573-903. All right. Okay, so I want to fork this. All right, and then we're gonna go ahead and download it and see if we can make use of it. I gotta sneeze. Hold on. I gotta sneeze. Sorry about that. I didn't want to sneeze right into the mic, and I can't really. I don't know if there's a way to mute this or not. Okay. All right, so let's go ahead and download this. All right. SSH. All right. Close this. All right. Cloud. Okay. This. All right. File. Open. Oh, I didn't even see what this was called. What is it called? Vehicle count detect. All right, so vehicle count detect. Vehicle count detect. Okay, open this window. All right, let's see if we can make use of this person's code here. And we won't go terribly much longer because I don't think that like things are necessarily going to go super great for me. All right, so this person's using a Jupyter notebook. Okay, no big deal. We'll just go, because I always have a persistent running version of Jupyter Hub on my personal machine here. All right, so vehicle count detect. Let's go into this Jupyter notebook. Let's see what's going on here. All right, so AWS just is starting their own live stream on LinkedIn too. I just got a notification of that. I just think it's funny because, like, you know, I obviously don't expect anybody to stay on this one. Let's go ahead and clear everything out here. I just want to see, because sometimes it's good to see what other people did, and try to emulate what they did to see if we can emulate the same thing. I don't even know if I have PIL installed on here. PIL stands for Python Image Library, and it's a library used for altering images in different ways. So, okay, so we are going to be fetching an image here using the curl. Okay, so this is working. All right, then we are converting this to a grayscale, and then doing a Gaussian blur on that, doing a dilation, loading the kernel. Now, let's see if this is actually going to work. Okay, because this is referencing this file here. But so if you're not familiar with this, Jupyter Notebooks can actually do what we call magic commands. I'm sorry, not magic. Well, there are magic commands, but this is not a magic command. I apologize. But if you want to run shell script commands in here, you just put an exclamation point here. So if I do an exclamation point ls, okay, because it's saying, all right, so required files. Okay, yep, that's what I thought. So, in fact, I don't like the fact it's just so hard to work with when it's not, when the directory is named kind of funky. So I'm just gonna rename this as models refactor. All right, there we go. All right, so models / okay. Okay, this is interesting. So, what is the way I am interpreting this is like it's basically like these are every single car that it recognized in here. So let's see if it will. Okay. Okay. Oh, okay. 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 This is very interesting because this might be exactly what I wanted to do. Okay, let's try the buses. Okay, models, bus. All right, so we found one bus in this particular image. Cars, models, slash, and then I think this is in the data directory, right? Data. Okay. Oh, interesting. All right, let's see how long it takes to run this. Might take a bit. Well, actually, I'm wondering what the contents of this video is. I'm kind of afraid to open it. Well, no, the reason I'm afraid to open it because, like, what if this person's actually got like pornography on here, and that would just be terrible. Cause, yeah, obviously, I don't want that to happen. All right, so, well, I don't see that. All right, right. Oh, I wonder if what it did. Yeah. Okay. Oh, this is really interesting. Okay. So what this is basically doing is it's loading up the video file from the source and then it's writing the video file back into there. So actually what we should be able to do is, okay, repos. All right, so cd vehicle. All right. Cd vehicle. All right, open dot. All right, and so what we should be able to do is open this file. I'll use VLC. VLC, the next video player. And it should show the result of the original thing, except with all the annotations on it. Okay. Okay. All right, let's play this. All right, let's see if this works. All right, but it says duration is 0. Off to a bad start. All right, well, let's see if QuickTime will play it. QuickTime, will you play this? Nope. Well, that's because it's an AVI file, but let's check to see if this file even works with like QuickTime here. Okay, so this is a 1 minute file, and I don't know if you can hear the audio of that or not. So what should have happened here is that this would get, but this is only 6 kilobytes, and what is the original file size? Okay, yeah, something went wrong here. Okay, the way I understand this though is basically it took this other file here. And then basically on top of this file annotated the bounding boxes appropriately and then saved it back as this result.avi file. AVI file. So yeah. Okay, so I've got a lot of good things to consider here. However, you know, I don't want to settle on this yet. But this is really promising. A lot of good stuff in here. Yeah, and my voice is starting to give out again. You know, this apparently happens around the 1 hour mark where my voice is just like, all right, we're done talking for today. Okay. So, video writer, okay. Video.write, video.release. Well, shouldn't this be like that? Here, let's try this again. Okay, that didn't work. I mean, it did it pretty quickly, so it appeared something worked. I just remember though, when we do open up this file, if it were to actually work, then it would be grayscale, and it would also have those pre-processing kind of things done to it, which again could be fine. It could be fine just from the sheer fact that like you know, I don't. No, man, I got a lot of different ideas now. Just thinking through this. Okay, I apologize that like I'm all over the place with this, but you know, I think there's some good stuff in here. All right, so it finished again. All right, what is the file size on this now? Still 6 kilobytes. So something went wrong. Okay, I'll have to research that. Okay, lots of good stuff for me to research. I think there's some good stuff in here. In fact, yeah, I'm not going to do anything else for today. Let's call it a day here. And I will pick this up tomorrow. Not in the live stream, but just my own personal time. So I at least hope you learned some stuff today. I mean, we didn't make a whole ton of progress, but we're going to continue along with this project and continue to add more pieces. So at the very least, we learned what CV2 is. We got our video started. Why does this look... Does it look zoomed into you? Or am I just crazy? I don't know why, but the screen kind of just looks zoomed into me. So I think, yeah. Let's go ahead and call it a day here. I'm sorry I'm a little bit scatterbrained because this is going to the Art Expo tomorrow. I wasn't really planning on that. And so now I'm simultaneously, because I just said I'll work on this tomorrow, but now I'm thinking, oh wait, I'm going to Chicago tomorrow. So maybe not. But that's the other thing. Even though I wish Apple made a proper 2-in-1, I do love this Surface. And one of the reasons I love the Surface is because it has the 2 cameras. So it's got the a front-facing camera, as you would see with any other laptop, but it's also got the rear-facing camera. And the rear-facing camera is super nice for these little computer vision kind of things. So, yeah, I might work on this tomorrow night from the hotel room. So, all right, that's all for today. Hope you all enjoyed the stream. Thank you for joining. Especially thank you to Kat for your comment in there. I look forward to catching up with you. And we will see you probably next week. Hope you all have a good weekend.